It is mathematically possible to take a solid object, shatter it completely, and build two perfect copies out of thin air. That sounds impossible because our physical reality operates on a strict rule. Matter is conserved, and volume can never be created or destroyed. If you take a heavy gold bar and slice it down the middle, the total amount of gold sitting on the table remains exactly the same. You cannot conjure wealth or add to the physical volume of an object simply by taking a blade to it. But what if our understanding of how an object can be cut is entirely wrong? Think about slicing a loaf of bread. No matter how many incredibly thin cuts you make, the total mass of the bread is locked in place. But consider what might happen if the slices we extracted somehow lacked a physical shape. If you take a wooden jigsaw puzzle and scatter it, those broken physical parts will only ever reassemble into their singular, original picture. Those pieces are bound by rigid, three-dimensional edges. They take up a specific amount of space, and their physical borders dictate exactly how they interact with the world around them. Now imagine puzzle pieces that are invisible. Instead of solid wood, they are made of endless, scattered dust. To understand how this works, we have to leave behind the physical world of chunky atoms and rigid edges and enter the boundless, unseen universe of pure mathematics. In this realm of pure thought, physical limits like mass conservation completely cease to exist. If we cut a sphere here, we don't carve it into thick slices. We shatter it into 5 distinct, infinitely complex clouds of mathematical points. These new fragments are known as non-measurable sets. Because these sets are composed of an infinite scattered dust of points, they are entirely porous. They completely lack a defined volume. And once a piece of an object loses its measurable volume, the concept of its physical size becomes a total illusion. Because these point clouds are infinitely sparse, they can be rotated and shifted through empty space. The points simply pass through one another without ever crashing. When you lock these ghost-like pieces back together, the reassembly suddenly fills twice as much space as before. Those 5 original fragments map together perfectly to form 2 complete solid spheres, each identical to the original one. This construction was published in 1924 by Stefan Banach and Alfred Tarski, revealing that in 3 dimensions, the very idea of volume depends entirely on how the shapes are defined. This image shows how this logic maps onto 2-dimensional shapes. Matching the areas of a circle and a square forces standard geometry to fragment into static-like chaos. That visual noise represents the staggering complexity required to bypass traditional volume. It demonstrates that our intuitive notion of size breaks down once we move from solid objects to sets of infinite points. So why can't you use this to duplicate a solid gold sphere in your kitchen? Real matter is bound by physics. It is made of finite, chunky atoms. It cannot be endlessly divided down into dimensionless points. The Banach-Tarski paradox relies on a singular, deeply powerful mathematical rule called the Axiom of Choice. This axiom gives mathematicians the authority to group infinite, undefined sets of points together, even when there is no specific physical rule to guide the selection. The Axiom of Choice can produce counterintuitive nightmares, but it remains a bedrock of modern math. It proves that numbers do not care about human common sense. We are trapped in a physical universe of absolute limits, but the unseen world of pure sets demonstrates that our 3-dimensional space behaves in ways that our physical tools can never replicate.